Hi everyone, and welcome to this quick little video on the optic pathway. So I got you to draw this out in the session, but people have requested that I do a specific video to describe this one a little bit more. So the first thing I want to do is actually just to focus on one eye, because it's a lot easier when you focus on just the one for the time being. And I'm going to use the words left and right for now. But what you can sort of see here is that if I describe this as the left visual field, and I will describe this as the right visual field, we can see how it sort of crosses over. And so this right visual field over here and here is crossing over, and it's being detected by the retina on the left side. So this would be the left retina. And then the left visual field here and here is being detected by the right retina. And so what we basically have is this giant sort of crossing over. And the sort of way that I described how this works before is, if you imagine I was to take two sort of lines like this, and I say that this is a bit of a representation of the iris, and this here is the pupil. Essentially, if I was to have one person stood here, so let's just draw a little smiley face there, and we have the retina over this side here, which part of the retina can actually see this smiley face? Well, this part can't see it, this part can't see it, this part can't see it, and this part can't either. But going through the pupil, this part can. And so essentially what you have, if the visual field is over here, it's detected by the opposite side retina, essentially. And so this is not only going to happen in the sort of left and right, this is also going to happen in the up and down. So anything on the floor is going to be detected by the superior portion of the retina, for example. I'm going to open this back up to both eyes, and I'm going to start using the new terminology. So between the two eyes, we've got a nose. Okay? And either side of the eyes, we have the temporal bones. And so what we do is we describe not only the visual field, but also the retina in line with either nasal or temporal positions. And so what we would say is that this is the nasal visual field, and this is the temporal visual field. And that would mean that this is a temporal visual field as well. And then when we think about the retina, we would say that this is nasal retina, and this is temporal retina. Okay? And then the other thing is to not forget, you need to explain which eye you're actually talking about when you start talking about the retina. So what we have first is we're going to say that the left nasal visual field is going to be detected by the left temporal retina. But then the left temporal visual field is going to be detected by the left nasal retina. And then we come over here, we have the right, because it's the right eye, the right nasal visual field. This would be the right temporal visual field. This is going to be detected by the right nasal retina, and this is going to be detected by the right temporal retina. Okay? So the terminology on this is, it's just going to take practice, basically. It's just remembering, are you talking about visual field? Are you talking about retina? which eye are you talking about as well? Because that will get sort of more useful if you don't confuse what's going on there. Now, the other thing that I've drawn with these visual fields is drawn as a box. And so you can see how I've sort of split it up into quarters. Now, the reason why I've got it split up into quarters is because it's showing that it's not only the sort of crossing over from temporal to nasal or nasal to temporal, but it's also happening in the up and down. And so the best way that I think I can sort of explain this is if you imagine now we're looking at the posterior eyes here. So this is the posterior, oh, that's an R. If we're looking at the posterior of the retina here, then essentially what you have is, we can see that we have this crossing over from one side to the other, but it's also going to be happening in the up and down. And so if I now take this color here and I change this superior portion of the left temporal visual field and I change that to green, or if I change that to yellow even, then not only is it going to be crossing over to the nasal retina, but because it's the superior portion of the visual field, it's going to be detected by the inferior portion of the retina. And so now if I was to make this portion yellow up here, once again, it crosses over and it crosses over again. And so this portion becomes the yellow. And so if I made this one over here into yellow, it's not only going to flip over to the nasal side, but it's also going to go to the superior bit. And so you can see here how the retina is detecting everything in a sort of flipped manner. Okay. And so this is basically the premise on how the eye actually detects things. So just swap these on the back. There we go. And then basically what I'm going to do from here, just to make this next bit make a bit more sense, fibers from each of these come together like this. Okay. And then sort of seeing how these travel together like this, that will make this next bit make a bit more sense. So if we now start following these fibers, so the red comes out and it goes straight through to the LGN. But the blue, this nasal retina, this will come out and it crosses over to the other side, to the LGN on the other side. But then this one here, because it's on the nasal side, crosses over and it goes there. And then this one also stays on the same side. And so you can see what's happened here because the left nasal retina and the right nasal retina have swapped sides. They're trading that information to the opposite side. And so what we have here, this is the optic nerve, and this is the optic chiasm. This is the optic tract. Okay, so optic tract, optic chiasm, and then this one here, the optic nerve. Okay, or cranial nerve 2. And so now what happens is the superior and the inferior fibers from the retina split off. So here I'm going to draw them bifurcate like that. And on this side, I'm going to draw them bifurcating as well. Okay. And so if I just take you back to this picture on the left here, essentially what I've just showed is that information goes off somewhere else. This one goes to the LGN. We then have this side come back over here, and then they split up again. Okay, so you can see how we have 1 and 2 from the superior and the inferior portions of the retina, and then once again they split off again like this. And so what we have is we have the superior retinal fibers travel through this way, and then we have the inferior fibers travel around this way. Now these ones pass through the temporal lobe, and these ones pass through the parietal lobe. So again, here we can see these ones pass through parietal lobe, and these ones pass through the temporal lobe. And that actually is all of it. But then where your understanding really starts to get stretched, or where the where your understanding really starts to get tested, is if you can identify what the blindness would be if you were to tear up a different portion of this tract. So for example, if I was to put a lesion straight through the optic nerve here, I'll call this number 1. What if I was to put a lesion through the optic chiasm here? We'll call that number 2. If I was to put a lesion through the optic tract, call that number 3. And if I was to get a lesion through this optic radiation, so that was one other thing I forgot to mention. After the LGN, all of these fibers are now called optic radiations. And how about number 5 be this one? Or actually, I'll do this one for the other side. Number 5 just here. Okay. So what we're going to do now is we're going to have a look and see if we can work out where the blindness is based on the lesion. So I always say follow the fibers with this one. So if we look at lesion 1, we can see that none of the left nasal visual field is going to make it back to the occipital lobe, and neither is the left temporal visual field. And so what that means is we would have total blindness in the left eye. If we look at number 2, we can see that none of the right temporal visual field is going to make it back, and none of the left temporal visual field is going to make it back, which means that we lose this. We look at number 3. Once again, we follow the fibers. We can see that none of the information from the right nasal visual field is going to make it back. So right nasal visual field is gone. Right nasal visual field. And where else? This one's the one that crosses over, which means that we're getting nothing of the left temporal visual field make it back. So left temporal is also gone. So this would be the blindness that's characterized. We go to number 4. So remember, these are specifically the superior retinal fibers. Okay. So as these are the superior retinal fibers, we're going to be looking at the inferior visual field. So the reason why I like to do the colors this way is because now my job's even easier, because I can just look at this and go, right, well, it's going to be the inferior portion of whatever the blue is. And so I look up here, is going to be the inferior portion of whatever the blue is, which is going to be this one and this one. So it's going to be left temporal visual field and right nasal visual field. Specifically, just the inferior portion because it's the right retina. Which means we come over to number 5. Now these ones are the inferior fibers, which means we're going to be losing the superior visual field of the red. So the red is the right side of each eye, but it's the inferior fibers, which means we're losing the superior portions up here. And that is the visual field or the visual pathway in as much detail as you will need it. Thank you very much for listening. Any questions, please do drop me an email and I'll see you in a bit.